Hi guys, welcome back. So we're going to continue working with our chemistry. In the last lesson, we took a quick look at how to read chemical equations and word equations. And in this lesson, we're going to take a look at how we can influence the rate of reaction. So how quickly chemical reactions occur. So in a chemical reaction, two or more substances reorganize atoms to produce new substances or other substances. Let's go back to last week's lesson. There's four things that can indicate that a chemical reaction has taken place. Can you remember what they are? Well, one of them is a color change. Now, a color change by itself doesn't always necessarily mean a chemical reaction has occurred, but if it occurs along with one of these others, then it's a good chance that a chemical reaction happened. A precipitate or a gas is produced or dissolved, so something seems to get used up, whether it's a solid or a solid or a gas are given off. If you see bubbles or fumes rising from the reaction, it's a chemical reaction. Heat and light can be absorbed or produced. If the heat is absorbed into the chemical reaction, then that's called an endothermic reaction because the heat enters the reaction. Whereas if heat is given off, like with the elephant's toothpaste that we looked at in the last video, that's an exothermic reaction because the heat energy is exiting from the compounds, from the reaction. And another important clue is that an odor is produced. So when we took a look at the assignment, burning toast was one. That smell of the burnt toast, that's a clue that a chemical reaction has happened. It's almost like a type of combustion, but it didn't quite light on fire. Yeah, still kind of a carbonation thing. So quick review from the last video. What do you call the substances that go into a chemical reaction? They're the reactants. What do you call the substances that come out of a chemical reaction? And yes, they're the products. We would read this as hydrogen plus oxygen produces water, or H2 plus O2 produces H2O. Now, I'm not going to play this video for you, but I did link it in the Google Classroom. It's about a 4 or 5 minute video. It does a really good job of demonstrating everything I'm talking about in this lesson. So they use the analogy of students trying to get through a crowded high school hallway as an example for looking at how to influence the rate of reaction, changing concentrations, adding energy, things like that. So I won't play it for you now, but you can go in and take a look at it before you do the assignment for this lesson. Excuse me. Okay, so a reaction rate, the reaction rate is a measure of how fast a reaction occurs, obviously. The rate of a chemical reaction can be sped up or slowed down by controlling four factors. First one, temperature of the reactants. So the more energy something has, the more heat that it has, it's going to react faster. The less energy something has, it means that it has less heat, it's colder, and it's going to react slower. It's one of the reasons why we keep our food in the fridge, because it slows down that decomposition, that chemical reaction, or oxidation in some cases. Think about when you're making Jell-O. When you add the Jell-O powder into the water, do you use cold water, room temperature water, or hot water? Well, if you've never made Jell-O before, you have to use boiling water, not just hot water, but boiling water. You need that extra energy in order for the chemicals, the molecules within the Jell-O powder to separate. If you were to use cold water, the powder wouldn't dissolve anywhere near as well. Now, don't be confused. Dissolving is not an example of a chemical reaction. I'm just using it here because it's something that most people could imagine in their heads. If you've never made Jell-O before, think about when you make ramen. When you make ramen and you open up that salty MSG fake soy sauce little seasoned package of goodness, that's the best part of ramen, I think. You put it into the boiling water. You don't put it in when the water is cold. You put it in when it's boiling because the boiling water has more energy. So thinking back to the particle model of matter, the particles are bouncing around more, so they spread out more. They diffuse. Okay, concentration of the reactants is another one. So if the reactants are more concentrated, they're going to react faster than if they're more dilute. Good example is when we took a look at the elephant's toothpaste in the last video. So the elephant's toothpaste reaction that I showed you was using about a 30% hydrogen peroxide solution. Conversely, the hydrogen peroxide that you buy from the drugstore or pharmacy is only about 3% concentrated. So the stuff that I used in that video is 10% more concentrated. If we use the more dilute hydrogen peroxide, you wouldn't get that nice plume of foam that comes out and shoots out of the flask and then spins around in the sink like a Dairy Queen ice cream cone or something. Um, so because the hydrogen peroxide, that reactant is far more concentrated, the reaction happens a lot faster. We can also use the surface area of the reactants to our advantage. So there's an example that I'm going to show you in this lesson here in a little bit with an Alka Seltzer tablet. We were going to do this lab upstairs as well. Sorry. If you want to try the Alka Seltzer lab at home, you're welcome to. The only materials you're going to need are like water, a glass, maybe a thermometer, and some Alka Seltzer tablets. If you don't have Alka-Seltzer tablets, you can use any type of antacid, Tums, Gaviscon, whatever. If your parents are anywhere close to my age, trust me, there's plenty of antacids in the house. Yeah. So with the Alka-Seltzer tablet, the greater surface area you have means that you've crushed it up. So Alka-Seltzer comes in a pill like this, a hard white pill. If you were to crush it up and put it in the water or in a weak acid, vinegar, lemon juice, something like that, it would actually neutralize the acid a lot faster than if you just dump the tablet in whole. And that's because if you dump a tablet in whole, the chemical reaction has to occur from the outside working in. And so the molecules or particles on the outside of that tablet have to slowly be dissolved and react in order for the stuff inside to be exposed. Whereas if you crumple it up, break it into pieces and dump it in, it's going to react faster. We'll take a look at that lab in a second. The last thing I want to mention before we take a look at the Alka-Seltzer lab is the presence of a catalyst. So with the elephant's toothpaste, the catalyst was that potassium iodide. We'll take a look at that in a minute. So if you wanted to try this lab, then just let me know. Send me an email or put a message, a comment here in the YouTube, and I can send you the lab right up for this. Basically, if you're not familiar with Alka-Seltzer, it's something that's intended for relief of headaches, body aches, heartburn, upset stomach, and acid indigestion. They contain mostly acetylsalicylic acid, ASA, or aspirin, sodium bicarbonate, which is baking soda, basically, and citric acid. And the citric acid is mostly for flavor as much as anything. Now, what we're going to do in this rate of reaction lab is answer this question. What factors will cause an Alka-Seltzer tablet to dissolve the fastest? And so based on the lesson that we just went through, you'd think about temperature and surface area, energy. Those would be the easiest ones to replicate at home or in a lab. So here's what you were going to do. You probably need maybe 4 Alka-Seltzer tablets. You're going to put one in cold water. You're going to put the whole tablet in. And then you're just going to stir it up and you're going to time it with your phone or whatever until all of the tablet has been dissolved. Dump it out, rinse it out, put cold water in again. This time, crunch up the tablet, put it in, and again, start timing. Stop timing once everything has been dissolved. Put all this into a data chart. Then you can use the hottest water you can get from the sink. And again, same volume of water. You're going to take a whole tablet, drop it in, and you might need to stir it to get it going, but time how long it takes for it to dissolve. And then the fourth trial, you're going to take that same hot water as close to that temperature as before. Measure the temperatures if you can to be exact. Crumple up the Alka-Seltzer tablet, put it in, and measure how long it takes for the whole thing to dissolve. Afterwards, we would take a look at this, which one would dissolve the fastest, which factors seem to have the biggest impact on it, and what factors seem to slow it down or decrease the rate of reaction. Now, if this lesson is correct, and trust me it is, then we would know that having the hot water and crumpling it up definitely causes the reaction to go faster. This was kind of a fun part that I added on for Station 5. We would do some maths to demonstrate the law of conservation of matter and put a balloon over the top so all of the gas that is given off gets collected by the balloon. And then we'd see that the mass of everything, the reactants before and the products after, should always be the same because matter is neither created nor destroyed. Okay, back to catalysts. So a quick final word about catalysts. A catalyst is a chemical that speeds up a reaction, but it's not consumed by the reaction. So back in the elephant's toothpaste there, we used the potassium iodide to separate hydrogen peroxide, H2O2. And it makes it go faster, but the potassium iodide doesn't actually get used up in the reaction. It's the stuff that colors the foam. Anyone who was in my science studies class in term three, we did this lab on people who didn't wear gloves like they were supposed to. Their hands got stained by the iodine, and it took probably 3 or 4 days for that stain to actually come out. The stain didn't actually come out, they just shed the layers of skin that had been stained by the iodine. Now, the opposite of a catalyst is an inhibitor. So an inhibitor is a chemical that slows down or stops a reaction. In the case of the hydrogen peroxide that I had used that 30% hydrogen peroxide from the garden center. It has a chemical in it called actinolide. The actinolide is a colorless powder that prevents the hydrogen peroxide from breaking down while it's sitting on the shelf in the store. When you buy things in the store, you know that they've been sitting on the shelf for months on end. So if your hydrogen peroxide is really old, you don't want it to have been decomposed or used up. It would be more dilute and therefore less effective. Okay, here's your assignment for this week. Go back through the films, the videos that I put up for you. Oh, am I showing my age, Sandham? Go back through the videos, go through that YouTube, the TED Ed video that I put up for you. Or you can just search these answers up on the internet. Answer these 10 questions, put them in a Google Doc, and turn them into the Google Classroom. If you choose to do this with a partner, just make sure that each person puts their answers in a different color so I know who answered which question. Okay, as always, if you have any questions about this week's lessons or assignments, make sure you contact me. You can email me, you can send me a Gmail chat message, you can request a Google Hangout or a Google Meet or whatever's going to help you. Remember, guys, your teachers are here to help you. We miss you. We hope you're staying safe. We hope you're having fun with some of the schooling. And if there's anything that we can do, let us know, and I'll see you next week.